Hi everyone, welcome back to the Comptia Network Plus course, Wired Connections. Back on Earth, wired connections use either copper, wire or glass fibre to carry bits as voltage or light pulses respectively. The attenuation issue I just talked about under wireless technology, where the signal gradually weakens over distances, also relates to copper wire transmission and limits the length of wire you can use. Fibre offers a lot more bandwidth and it's a lot less susceptible to noise, but it also costs a lot more to buy and install in the United States. The standard for synchronous data transmission on optical fibre is called Synchronous Optical Network, Sawnet. The international equivalent of Sawnet is Synchronous Digital Hierarchy, SDH. Sawnet defines a base data rate or throughput of 1.84 megabits per second, and multiples of this rate are known as optical carrier OC levels, like OC3, OC12 and so on. Table 16.2 depicts common OC levels and their associated data rates. Level OC1 data rate 5.84 Mbps, OC3 155.52 Mbps, OC12 622.08 Mbps, OC48 2.488 gigabytes per second, OC192 9.953 gigabits per second, OC768 39.813 gigabits per second. Regardless of the media used to carry WAN traffic, the growing volume of voice and video traversing data networks has led to new traffic problems. Regular data traffic can arrive out of order and be reassembled back into its original order on the receiving end, but voice and video data require real-time delivery to be intelligible. Clearly, this makes regular data a lot less vulnerable to congestion or busy traffic congestions that can delay voice and video communications and totally mess them up. The exploitation in the popularity and the amount of multimedia being sent over data networks is a big reason the never-ending quest for greater bandwidth and speed to avoid traffic jams over WAN links is so vital today. Wavelength division multiplexing. Wavelength division multiplexing, WDM, is a technology that multiplexes several optical carriers on a single optical fibre by using different wavelengths. Remember, fibre optic signals are light, so using different wavelengths of the light spectrum is somewhat like using different frequencies in a radio wave. Dense wavelength division multiplexing, DWDM, multiplexes within a specific band 1550 nm, allowing for the use of erbium doped fibre amplifiers, EDFAs, to boost the signal. This allows for upgrading the bit rate of a single strand line by simply replacing equipment at either end of the line. The system consists of the following: DWDM terminal multiplexer, intermediate line repeater, intermediate terminal multiplexer, remote amplification site, DWDM terminal multiplexer. Coarse wavelength division multiplexing, CWDM, uses larger chunks of the light spectrum and is defined by wavelengths, whereas WDM is defined by frequencies and fits 40 plus channels into the same frequency range used by just 2 CWDM channels. So why use CWDM at all? because CWDM can match the basic capabilities of DWDM at a lower capacity at a significant discount. This allows ISPs to help customers in a metropolitan area network (MAN) physical location where fibre is still too pricey to implement. Passive optical network. Passive optical network, PON, also called fibre to the premise, is a new option for connecting homes and businesses to the internet. It is a point-to-multipoint technology with a single fibre strand used for multiple premises, typically 1628 unpowered. Optical splitters are used in the process and are the reason for using the term passive. The system consists of an optical line termination (OLT) at the telco's office and a number of optical network transmission units (ONUs) near end users. These systems typically have downlink speeds of 155 to 655 Mbps and uplink bursts to 155 Mbps. Wireless technologies. Now let's get back to that distance issue. You know that different technologies offer different distance ranges and that optical fibre carries signals much farther than copper cabling can. You also know that fibre comes with a much higher price tag to match its higher capacity and that it's much harder to install. By now, most of us know what Bluetooth is, a type of wireless technology that's only used for short distance wireless transmissions. Bluetooth is actually a wireless protocol that creates personal area networks (PANs). It utilizes short range communications technology, enabling data transmission between fixed and or mobile devices. Most of us have mobile phones, and those of us who have smartphones can even get their email, news and directions to where they're headed, not to mention the best Italian restaurant. They can tell friends where to meet them and post it all on social media in real time, but it's already illegal to talk on your cell phone while driving in some US states. As time goes on, likely more if not all. Even using a wireless headset while driving can get you in trouble in some places. Those headsets, along with wireless keyboards and mice, all use Bluetooth technology. Bluetooth uses a radio technology called frequency hopping spread spectrum that chops up the data being sent and transmits chunks of it through the air on up to 75 different frequencies in the 2.4 GHz range. The transmitter and receiver change frequencies or channels in a prearranged pattern, getting all of our wireless toys to play nicely with each other, and sync up can be a hassle initially, but meeting that need is exactly what the people who created Bluetooth intended to do: develop a signal digital wireless protocol capable of connecting multiple devices and overcoming problems arising from trying to synchronize them. Bluetooth achieves this goal, and it even allows us to sync our cars with our phones to chat away legally while driving again. Microwave radio relay is a technology for transmitting digital and sometimes even analog signals between two locations on a line-of-sight radio path through the atmosphere. During microwave radio relay, radio waves are transmitted between two locations with directional antennas that form a fixed radio connection between them. A really long connected series of links can form line-of-sight transcontinental communication systems, although having a dedicated microwave connection is still common. because it allows you to purchase your own frequency range from the FCC to ensure that you don't get any interference. A much less costly installation is the wireless 802.11 specification, which provides us with long distance solutions and a healthy amount of bandwidth to boot. A communications satellite, ComSat, is an artificial satellite stationed in space for telecommunications purposes. Modern communications satellites use a variety of orbits. Here's a list of them. Geostationary orbits, Molia orbits. Molia means lightning in Russian, named after a series of communications satellites from Russia. Low polar and low polar Earth orbits, from which satellites can first boost communications signals and then send them back to Earth. This technology is also used for mobile applications like GPS communications and to ships, vehicles, planes and handheld terminals, as well as for fun stuff like watching football on satellite, HD TV and radio broadcasting. These all require capabilities that are impractical or impossible to use with other technologies like cable. So yeah, this satellite thing is pretty awesome, but of course it comes with a few problems too. First of all, it's expensive, and although it isn't necessarily slow, there's a lot of latency because it takes time to get from your terminal to the satellite to the provider and back. This is totally understandable since you're transmitting about 20,000 miles or more, and once you get a good TCP stream, something like an FTP download, speeds really get moving. Still, for bursty traffic like email messages, you'll probably encounter enough latency to drive you batty enough to head straight back to a modem. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, subscribing. Thank you.